Hello, my warriors. Time to crack the advanced problems of EMI. Get battle ready with me, Shreyas, your physics master teacher at Vedantu, going live. Hello, Surya. Hi, Riya. Manpreet. Herewith. Hello, Kiran. Ramesh. Hello, Rushendra. Hello, Thashwent. Hello, Vishal. Hello, Chitra. Hello, Hari. Hi, Pradeep. Hi, Vidyashankar. Welcome, welcome, welcome. Lots of fire, lots of hearts, lots of love, lots of yo's, lots of we's. Thank you guys very much. Looks like you guys were really waiting for this session. And those of you are very new to this channel and probably even Vedantu. First of all, welcome to Vedantu, India's first institute to start online live classes. And welcome to Enthuse, which is the exclusive JEE English medium channel. And this is me, Shreyas, your physics master teacher. I not only teach on this channel, but I also lead the physics department of JEE division, and I have been training kids for more than a decade. And many of my kids are in IITs, in the top-notch institutes, and many of them have even graduated from these institutes. And I really hope this channel becomes the gateway for your success. So have faith, have trust, keep enjoying, keep solving the problems. That's it. All right. And if you want to know more about me, you can definitely follow me on my Instagram handle. That's Shreyas_Vedantu. There is a busy week coming up ahead, and especially for the 2021 students. So, balidan dena hoga kisko 2022 and 2023. Why? What is the meaning of balidan? It's sacrifice. So balidan kyun dena hoga, guys? So the reason is, there is a JEE Mains coming up. So your seniors need your help. Your seniors need your support. They need our support. They need our help for the lectures which are going to come up. So we are planning mock tests for the outgoing batch. And then tomorrow I'm going to come in the NEET channel for the NEET examination. That's on biotonic. Sure shot 60 again for the outgoing 2021 students. And Thursday and Friday there will be the actual JEE Mains paper. So those discussions will be happening live over here on this channel. So if you know somebody who is writing JEE Mains and they want to know how the paper is, and if they want to know how the previous papers are of the previous shifts, then they should attend these sessions. And a similar advanced session, you can also attend it even if you are in 12th. That's on Newton's laws of motion. That's on Saturday. Newton's laws of motion advanced problems. Yes, I had an amazing Raksha Bandhan. Thank you, Ankit. And these are the Rakhis. So I have 4 Rakhis right now out here. Thank you, Crazy. Chegabuda. All right. Hi, Surplus. Hello. Okay, great, great. So guys, I hope you have attended my previous session where I talked about how to clear backlogs. Use this week for clearing backlogs. Where are you going to clear your backlogs from? See, I will show this to you. You have to clear your backlogs from here. On our channel, go to playlists. Okay, just click playlists. There are different tabs. This is community. In community, you will see all important posts. Like I'm coming on NEET channel, so this is a post. If I update a timetable of the, or if there is some important notification, it will be put up on the community. Then go to playlists. Over here in playlists, you will see there are different kinds of sections. Go to the JEE Physics section. Click on this. Okay, the JEE Physics section. You will see there are multiple smaller playlists over here in this section. The playlist that will be useful for you is the Pathfinder. This playlist has all the lectures of the Pathfinder, but they are not segregated chapter wise. But it's from the first till the current lecture. If you want the chapter wise playlists, they are here. You can see electrostatics playlist, 6 lectures. Gauss's law, 5 lectures. Current electricity, 7. Capacitors, 5. Magnetic sources, magnetic effects, all this 5, 8 lectures. EMI, 7 lectures. All of that is here. So these are the lectures from which you're going to revise it. Is that clear? If it is clear, put up a thumbs up in the chat box right away. Great, Kiran says, all right. Can this session help me for JEE Advanced 2021? Absolutely, Praveen SPP. Definitely. Even if you're a 2021 student and you have confidence over your JEE Mains and you know that yes, JEE Advanced is my next target, please attend all my advanced sessions, even though they are for the lower grades or for your juniors. They will eventually help you. All right. So let's get going. And Well, I have talked about Cengage. Cengage is not a good book that should be used. I have already spoken about it. Okay, Ankit, whether you like chemistry or whether you don't like chemistry, you have to do it, bacha. There is no substitute for that. If somebody has told you you can only study 2 subjects and clear JEE Mains, that's wrong. Remember, I have seen numerous students over the past decade who study only 1 or 2 subjects properly. The third subject they ignore. Never do that. They never get good marks or good rank. They might clear JEE. It's enough to just probably get the last rank somewhere in a random NIT, random branch, but it is of no use. Alright, now also let me also congratulate all our students who are passing out this year to give us these amazing results, and it makes me feel proud that I am a part of a system. I am leading so many students. I am, nurturing so many students who are giving us, that confidence that yes, we can go ahead, whatever our ambition, our aim is to, make sure that every child learns, every child gets the best of the teachers with the best material, all of that, sitting at home. And, this is like an assurance. This is like a motivator for us that yes, we are on the right track. I mean, look at this, 4 out of 5 students of Vedantu are already qualified for JEE Advanced. So many students getting 100 percentile, qualifying Olympiads, acing it in boards. I mean, the results have been tremendous, and even from the first attempt till the third attempt of this year's JEE Mains, we have shown more than 7 to 8 times improvement in the JEE Mains results. Thousands of students above 90 percentile. And all of this is because of all our teaching methodologies, our material, our doubt solving abilities, our multi-teacher model, and also the subscription model, which allows you to replay the classes, attend anybody else's classes, see the micro courses, enhance your skills, which are tailor-made for your needs. So all of this in the pro subscription. If you are interested, go ahead, check out the link which is there in the description box. Use my coupon code SHHPRO to get 10% off. Do not waste that extra 10%. Make sure you get that discount. Okay, it's hardly 3,000 rupees per month for the light version, and for the plus version it goes to 5,670, where you also get the personal mentorship. That's what it is. Let's start with the first question coming up on your screen, and here it is. Relaxing diaries. I have already solved many NTA mock questions in my previous mock test, bacha, so you can check it out. Although I have not exclusively labeled that lecture as NTA series, I have taken up many NTA questions in my previous mock test in the playlist. You can check it out. Okay, cool. Is PYQ enough for JEE Advanced? Definitely not. PYQ is not enough. It's just barely enough to get you a random rank, a last rank probably in JEE Advanced. No, it's not completely enough. Thank you. Glad to know, Nikhil. It was very useful. Please cover up your backlogs, guys, in this 1 week. Meanwhile, you're sacrificing this time for, our time, so that we can utilize it for your seniors of 2021 batch. This is matrix type. Now, what is the meaning of matrix type? See, in matrix type, one option might match with more options. Okay, one to many. Maybe A goes with P, Q, R. Maybe B goes with P and R. Maybe C goes with R and S. I don't know. It would be anything. So this is the diagram. The situation is given. You have to fill up the table in that, in your OMR sheet, or if it is online, then you need to click it properly. So A is to P, Q, R, B is to Q and S, whatever it is, you need to click it properly. Anyways, now let's not worry about how to fill the matrix match. Let's solve this problem. Read this question. So this question is all about, there is a wire which carries current, there is a loop beside it, and the funny part is the result is in the first column, the experiment is in the second column. This is what you are doing. This is what is the outcome. Usually what you are doing is in the first column and the result is in the second column. This is often the technique used by examiners to confuse students. They'll be like, oh my god, how do I solve this? I don't know. Is the induced current clockwise in which all scenarios? No, don't do that. Don't do that. Relaxing diaries, this will be little bit tough for NEET, but yes, you can observe, no problem. But don't take it too hard in case you find it difficult. Now, I'll tell you what, start from this column and go to this column. That will be better. Take cases. You can see current is increased. Current is, I think, one of the option should be decreased probably. This should not be increased and increased. This was decreased, I guess. This was decreased. Okay, this was supposed to be decreased, I guess. Okay, so current is increased in the wire, current is decreased in the wire. The next two options are wire is moved away and the wire is moved again towards, it should be, I guess. This should be towards. Okay, looks like there was a printing mistake over here. So all the four cases are there. Yes, all the four cases are there. Now let's solve any one case over here and one case over here. Automatically you will get the answer for the second case. Do you guys understand this? If I solve P, all the signs, directions will be opposite for Q. Agreed or disagreed? Do you guys agree? Let me know by giving a thumbs up or writing the word agree. Similarly, if I solve R, I automatically solve S, because instead of moving away, you are moving towards. Everybody getting this point? So actually, how many options are you solving? You are only solving two options. So it's very important that you analyze the question first for solving advanced. It's not about, sir, start with the solution, sir. What is the solution? Come on, tell me fast. Wait a minute. First analyze the question. This all these thoughts should run through your head. Okay, so let's solve maybe P option. Okay, let's just solve P option. Current is increased in the wire. What will happen if the current increases? Now because of this current, use your right hand thumb, point the thumb in the direction of current. The right hand fingers will curl this way. So that means the magnetic field which is there, the magnetic field will be inside. Now this magnetic field, okay, I'm talking about option P right now. This magnetic field, because the current is increasing, this magnetic field will increase. It will also increase. Everybody gets this? It will increase. Okay. Now if this magnetic field increases, the flux will increase. If the flux increases here, by Lenz's law, there should be EMF induced in it. So by Lenz's law, how do you oppose this increase? It's increasing inside. You have to oppose by creating field this way. Oppose it. It's increasing there. Oppose that this way. So hold your thumb this way. Your fingers will curl automatically like this. So there will be current induced in this direction, which will be anti-clockwise. Yes, there will be EMF induced. There will be current induced in the anti-clockwise direction. Now, because of this current, what will happen? There will be a induced field, and that induced field will be towards you. Induced field will be towards you. And this coil will also have a magnetic moment. So the magnetic moment of the coil will be also towards you. Look at that. The current is like this. Area vector will be towards you. So there will be a magnetic moment towards you. Now, if you look at the options vaguely over here, you will quickly understand the induced current is in the clockwise or anti-clockwise. So P goes with B. P goes with B for sure. The wire will attract or the wire will repel, and will there be a torque? Well, the torque will not be there. I'll tell you why. Because magnetic field from outside, this is your external magnetic field. This is external, and magnetic moment, both are 180 degrees apart. Remember, torque is nothing but mb sine theta. This theta is 180 degrees. So sine theta will be 0. So torque will also be 0, bachalo. Why is theta 180? Look at this. The magnetic moment is towards you. The magnetic field from this coil is inside the plane. So don't you see it is 180 degrees, guys? So 180 degrees, sine 180 is 0. So the torque is 0. Great. Thank you, Aditya Bacha. Okay. Now the torque will be 0 in both the cases. There will be no torque. But will the wire attract or will the wire repel? That's easy to understand. Think about it. See, guys, the magnetic field which is induced, is coming out of the coil, right? The magnetic field which is induced is out of the coil this way. How will it go? Like this. It will go like this. Visualize. It will go like this, go from behind and come like that. Magnetic field which is induced by the coil. Think about it. Now, visualize this, guys. These magnetic field lines which are induced, this ones, okay, this ones, the magnetic field which is induced, yes, they will come out, but when they pass through this wire, they will go inside, right? Because they'll come from here and go like this. They'll come from here, go like that, come from here, go like this. See if you're able to visualize this. If the magnetic field is going inside, on this wire, there will be a force. What is that force? Force will be ILB. This B is because of the induced. This magnetic field will apply a force on the wire. What's the direction? L is upwards because current is up. Magnetic field is inside. L, B. L cross B. See where is the force? This force is going to be this way. What is it? This is going to repel it. Do you see that? It is going to repel it. So hence they will repel. So that means the correct answer for P will be this as well as this. See if everybody has got it. Okay. Okay. Everybody clear? Everybody clear about this? Very good. Very good. Okay. Now, similarly, for the decreased part, what will be the answer for decreased? It will be A and C, because everything will be opposite. If current is decreased instead of increased, the current will be, this one. What will you say? Yeah, where do we go? Yeah, Q will go with this part as well as this part. Everybody fine till here? Everybody fine till here? Let me know. It will go with A and C. Okay, clear. Now, the last part, which is R and S. See, once you solve P, automatically solve Q. Similarly, if you solve R, you will also solve S. Now, I will clear all these things because I don't need most of these things right now. If the wire is moved away from the loop, then what will happen? See, this wire is creating magnetic field inside. This wire is creating magnetic field. As you go close to the wire, the magnetic field is very, very strong. And as you move away, the magnetic field becomes very, very weak. So it is very strong here. It is very weak over here. Now just visualize, if I move this wire over here, then what will happen? The weaker field will pass through the coil. Do you see that? The moment I move this coil here, understand the distance between them will increase. Weaker field will pass through the coil. So can I say the flux which is passing inside will become weak? It will become weak. It will weaken. It will weaken. Everybody agrees? Now if I see that the flux will become weak, that means by Lenz's law, think what should happen. By Lenz's law, it is becoming weak. Do you strengthen it? You help it. Where is the flux? Inside. So if the flux is inside, strengthen it. How do you strengthen it? By, producing induced field in that same direction. If you produce field in inside direction, use your right hand, point the thumb inside, fingers curl like this. So the current should be in this direction. So the current should be in this direction. Okay. So now let's see what will happen. By the way, this was decreased and this is moved towards. Okay. So think if the current is in that direction, B induced is in that direction. First of all, where is the current? The current, if the wire is moved away, the current is in the clockwise direction. Check this out. Option A will be correct. Everybody fine till this point? Everybody fine till this point? Just check this out, guys. Yeah, everyone fine? R goes with A, cool. Now, next point. Will there be attraction or will there be repulsion? For that, think this way. The induced field is inside. So that means, how is the field coming out of the coil? Think, it will come like this and it will go inside the coil. See, visualize this, visualize this. The field is coming from here and it is going inside. It's coming from here and it is going inside the coil. So it's coming like this and it is going inside. So that means the magnetic field over here is towards you, right? The induced magnetic field is towards you. So if you calculate the force acting on this wire, this force which is IL cross B, length is there, current is there, so length is up, magnetic field is towards you, so use L cross B. See where is the force. This force is going to be this way, that means it is going to attract. So hence the answer for that will be attract. So R goes with this. Naturally S will go with this option and this option, exactly opposite options. That's how you need to solve it. Everyone fine? Everyone fine till this point? Cool. So no problem, no problem. Yes. Everyone, somebody is joining late. Zayed, join in, bacha. So what's the difference between Usain Bolt? My God, what nonsense question. Okay, chalo. Let's get going to the next question coming up on your screen now. But before that, let's just verify the answers. Yep. So A goes with QR. C also will go with QR. B will go with PS. D will also go with PS. That's how you need to do it. Everybody loving this question? Shall we go ahead? I hope you guys are not giving up. By the way, if you are preparing for JEE Advanced, you need to attend this class. If you are in a passing out batch, or whether you are a 12th standard student, you should be used to these kind of questions. If you give up right now, trust me, there is no way somebody can push you up later on, okay, from no matter which coaching institute you join. Okay, so that's very important. You cannot give up probably at this point of time. Let's go to the next question coming up on your screen now. There is a coil of inductance L and there are two rails as shown. There is a connector of length L and mass M, and it can slide freely over that rails. The entire setup is in a magnetic field. You can see it's inside the plane of the page. At some instant the velocity is V0 and it is imparted to the rod, and it starts moving. The displacement of the connector will be by which particular diagram? Which diagram shows how the displacement will change with time? Now, lot of Henil for advanced NCERT is not even enough, bacha. I have mentioned in my previous lecture. Just watch my previous lecture, which all books you need to solve. Just check it out. JEE 2022 alert. Yeah, that's the session. You need to check it in the past videos of the same channel. Okay, cool. Now, hi Trapti, yes bacha, I do remember. Okay, now let's see, some of you are saying A, some of you are saying C. It's not so easy problem. It's not so easy problem. Surely Ricky, I'll see you tomorrow on Biotonic as well. First of all, try to understand what happens the moment this rod gets some velocity V. Say if it gets some velocity V, there will be an EMF induced. And what is the EMF? EMF is always in the direction of velocity cross B. Velocity is there, magnetic field is inside, so V cross B is that way. That means there will be a current which will be set up this way, and that current will flow through the inductor and back over here. So there will be some current which will be set up in the circuit this way. Everybody clear? So this EMF will create some current which will be EMF divided by the resistance. Okay, I don't know, maybe I will get the current by some other way also. I don't know, because there is no resistance specifically mentioned. Now, the moment there is a current, there will be a force by the magnetic field, IL cross B. Remember, that's the force by the magnetic field. So what will be the force, guys? Look at this. IL cross B, current is there. So IL cross B will be the force. Current is upwards, that means length is up. Magnetic field is inside. L cross B. Length cross B. That will give me the force this way. So the force acting will be over here. This force in magnitude will be ILB. That means this force is surely going to cause some acceleration or retardation. Why will it cause retardation? Velocity is there, force is this side, so definitely it will oppose the motion. So there is going to be some retardation out there. Great. That's why the velocity will change. Now, here is what we are going to do, guys. If I start with Newton's laws, okay, let's say we start with Newton's laws. So with Newton's second law, can I say that force is result for the acceleration, and that force is nothing but ILB, and probably I can write acceleration as dv by dt, but this will be negative because it is retarding, minus dv by dt. Just check this out. Everybody fine till this point? Let me know if this is okay. This is minus dv by dt because it is retarding. All I have done is applied Newton's laws. What am I trying to do? See, the question was to draw the graph. It's not so easy. You cannot say, sir, current will increase and then decrease. How do you say that? You do not know anything. You need to get an equation. There is no formula for current, for this situation. You don't know the formula. You have to derive that formula. So let's see how do we do that. If everybody is fine, yes, Rapti and Ria says yes. Very good. So Hemant Bacha, I have already made a session for JEE 2022. Watch it for 11th revision and for how to solve problems, etc. I have just made a session. Please watch that, Bacha. Okay. Now, the next thing that I'm going to do is, see, by using, the Kirchhoff's voltage law, here is what I'll say. There will be EMF generated over here and there will be some voltage drop across the inductor. The sum of the voltages should be 0. So, BLV minus L di by dt should be 0. You start from here. BLV is the voltage difference, that's the motional EMF, and L di by dt is the voltage drop across the inductor. So this part was nothing but your motional EMF. We have seen this formula, motional EMF. Okay, just rearrange it. So I'll get BLV is equal to L di by dt. Interesting. Acha, over here I am seeing dv by dt. So the moment I see dv by dt here and there is velocity, I feel I should rearrange this term like this. V is equal to L by, this is BL, and di by dt. Don't ever cancel this L and this L. The capital L is the inductance, the small l is the length of this rod. So do not cancel, they are not even dimensionally the same. So be careful. Therefore, dv by dt, can't I say it is L by BL, derivative of I with respect to time's derivative will be d square I by dt square. Correct? It will be d square I by dt square. Now it's simple. I'll tell you what you need to do. Just look at this equation. It is ILB is equal to minus M. Instead of dv by dt, substitute this. Just substitute this and see what will you get. You'll get L by B small l d square I by dt square. Shift it over here and see what you will get in the next step. You'll get M L by B small l d square I by dt square plus ILB is equal to 0. Now stop, you don't need to do anything. Trust me on this. Next 1 or 2 steps is the answer. How? Observe. This is a constant. This is also a constant. I is a variable. Second derivative of I is also a variable. Isn't it looking of the form something like K or like this? Mx second derivative. M second derivative of x. Second derivative of x plus kx is equal to 0. This was for spring mass SHM. K spring and mass SHM. So isn't this also an equation for SHM, guys? Everybody agrees to this point? Everybody agrees for this point? Yep. So Jaideep, you can watch this video for 2021 also. Watch this, don't spam out here. So isn't this an equation for SHM? How constant? Because mass is constant, inductance is constant, B is constant, length is constant, B is constant. So all these are constants. Only current is changing in this equation. Now once you see that this is an equation of SHM, that's it. So current is a periodic, it's a periodic function of time. If current is a periodic function of time, think about it. The force which is ILB, will also be a function of time. In fact, where is it? Look at this. Di by dt will also be periodic. Di by dt will also be periodic. If di by dt is periodic, even velocity will be periodic. If velocity is periodic, even position will be periodic. Do you see that? All are periodic functions. So that means the graph will be like a sine or a cosine graph, and that's the answer. Everybody got this step? So the moment you have an inductor and a moving rod, the first step was to prove that it is a SHM. The moment I found out that any one variable is periodic in nature, substituting that, the moment I is periodic, di by dt is periodic, di by dt is periodic, so velocity is periodic. If velocity is periodic, position is also periodic. As simple as that. So that's what I've done, and therefore the answer will be this one, this graph. It's a periodic function, sine or cosine graph. That's the answer. How many of you loved this question? How many of you loved this question? Let me know. Interesting question, right? Nobody would think that you had to do so much of maths behind the scenes. That's what advanced is all about. A lot of channels do not show you the true advanced questions. A lot of channels hide the advanced questions, and we are not like that. We want to make sure that you know what advanced questions are, because I know ultimately your goal, most of you, is advanced and you want to get into IIT. If you want to get into IIT, you need to solve these problems. If somebody has told you, no, there are easy questions also in advanced, yes, there are easy, but there will be hardly few of them in number, but most of the questions will be of this level. Okay, chalo. Let's get going to the next one, and here we come. Jaideep, we have a special series, we call it Killerify, but we'll do it after. That's our channel specialty, which is called as Killerify, and we'll be doing it after the JEE Mains, not before that. And there is a lot of surprise, Jaideep, coming in for all of you, for especially the JEE Advanced aspirants. If your percentile is already above 97, you will already be a part of Eklavya. If your percentile is below 97, obviously you will be preparing for JEE Mains. You will not be foolish to prepare for JEE Advanced, because if your percentile is below 97, that means the chances of getting a good IIT or a decent branch will be very less. So obviously you will try to improve your rank and make sure that you at least secure a seat in NIT, and then only prepare for advanced. Alright, so that's how it is. Cool. Let's get going to the next question coming up on your screen. Again, probably might involve derivatives and integration. So there is a charge sphere. I'll spare you the reading. There is a charge sphere, and it is connected via an inductor and a switch to an uncharged sphere. The moment you connect and turn on the switch, what do you think will happen? The charges from here will flow over there. But the problem is, okay, I think this second part was not asked. Okay, this was not asked. We just had to do only the first part. Okay, just ignore this for now. Okay, find the charge on the sphere as a function of time, because if you find the charge as a function of time, you can also find what is the time at which the charge will be q by 2. So let's focus on how to find the charge as a function of time. Let's utilize this time in this session to find out and understand the concepts more than solving many questions which will be useless. So this part will be a part of this question only. Okay, let's do this. First of all, do you agree that the charges won't flow instantaneously? Why do you think the charges won't flow instantaneously? Why do you think the charges won't flow instantaneously? Think about it. Because of somebody. Who is that somebody who will prevent the charges to go from A to B instantly? Think, come on my warriors. Come on Riya, Zayed, come on. Ankit, everyone out there. Yes, Neeraj, perfecto. There is an inductor. So that will prevent it. So the current will slowly grow. So the charge will also slowly grow. Let's say the current in the circuit is I. Current is flowing. This charge after some time will probably become Q minus Q, because Q charge has gone over here. Look at this, Q charge traveled because of the current via the inductor and the switch to the other side. The total charge is obviously conserved, you can see that. Now, I think we should use Kirchhoff's voltage law, or just think about, what is the voltage of A and B. It will keep on changing, and it will keep on changing till their voltage difference is 0. See, earlier this was charged, this was not charged. So there is voltage difference. That voltage difference is causing the current to flow till both of them stabilize at the same voltage. Achha. So at any time, at any instant, can I say that the voltage difference between A and B is the voltage difference across that inductor? Check this out. Because in this entire circuit, between these 2 points, there is only one element, and that is the inductor. Whatever is the voltage difference here is the same voltage difference here, because everything else is a wire or a switch. Correct. So what is VA? Well, VA is the voltage of this sphere. What is the voltage of this sphere? You remember this from electrostatics. It is K into the charge divided by R. This K is your Coulomb's constant, 1 by 4 pi epsilon naught. Q minus Q is the charge divided by the radius. That's the potential. Yep, clear. Now, minus VB. What will be the potential of this guy? The potential of this guy will be K Q by small r. Capital R. K small q by capital R. Voltage 1 upon 4 pi epsilon naught Q by R. That's the potential of a sphere or a shell. Everybody knows that. Similarly, what's the voltage drop across the inductor? Standard L di by dt magnitude wise, because we are taking higher minus smaller. So L di by dt magnitude wise. Okay, because high minus low should be a positive number over here. Now what do we do next? Interesting. So once I have the potential difference out here, probably I need to move this around and see what do we get. Okay, chalo, let's do this. K divided by R, and I will have over here Q minus 2Q, okay, is equal to L di by dt. Interesting. Now something is suddenly clicking me. Something is suddenly clicking me. I'll tell you what is clicking. See, here, if I look at this number inside the square brackets, this is something like charge. This is like charge. Some charge function is there. Okay, some charge is there. This is derivative of current. Current is dq by dt, derivative of charge. So isn't di by dt the second derivative of charge? The second derivative of charge. Everybody agrees to this? That means, Bachcha log, this is an English channel, so obviously Kishore, I'll be talking in English, not in Tamil. Okay, so I don't know, there might be Tamil channels also, but we will be talking in English only. Okay, so all these days you wanted an English channel, you didn't want an Hindi channel, so now we have come up with the English channel. Now you are asking Tamil channel. Tomorrow we'll ask, sir, I want this dialect channel. Tomorrow I want AP channel. Tomorrow I want this channel. Guys, focus on the session. All right. Now, second derivative of charge. This clearly tells me this is somewhat similar to SHM equation. It's very similar to SHM equation because you had constant, let's say for example Q, and if it is equal to some other constant into second derivative of Q, if I shift it over there, you know, you will get SHM equation. Think about it, because if I shift it over there, I'll get, let's say, plus, and this is equal to 0, for example, ignoring the signs. Okay, so I'm going to get a SHM equation. So this is SHM equation. Interesting. This is SHM equation. That means I can do one funny thing now. I'll tell you what. Okay, let's see what I can do. Let's try to move this around, and let's try to write it as L di by dt is equal to minus K by R, and I will take Q, 2Q minus Q over here like this. I will take it on the other side. Now the next step is, look at this, the next step, I will differentiate this. I will differentiate this and see what do I get. Okay, so by the way, I can also shift this L below over here, RL. di by dt is already the second derivative. So it is d square q by dt square. So di by dt is already the second derivative of the charge, and this will be equal to minus K by RL. In fact, I can also take that 2 outside, and I will get this as Q minus Q by 2. This is what I'll get. Now shift this over here. I will get d square q by dt square plus 2k by RL, and here I will have q minus q by 2 is equal to 0. Now I don't need this anymore. Observe this particular equation. If you take this variable as x, if you take this complete variable as x, think what dx by dt will be equal to. Dx by dt will be equal to q by 2 is a constant, so you are just going to get dq by dt. If you take the second derivative, that is d square x by dt square, what will you get? You will get d square q by dt square. That means this entire thing can be written down as d square x by dt square, and this is some constant, into x is equal to 0. Isn't this all an equation of simple harmonic motion? Isn't this all an equation of simple harmonic motion? If you notice this entire term inside the bracket, if I substitute it as x, dx by dt will be q's derivative, that's it, it will be dq by dt, and because q by 2 is a constant, and the second derivative will be d square q by dt square. Hence this is an equation of SHM. Hence what will be that equation? Think about it. That equation will look something like this. X, remember I have substituted it as x, so x will be some x naught sine, alright, omega t plus phi. But don't use x, I will use q. I will use the original variable, which is q. So that original variable is q minus q by 2, q minus q by 2, that's the original variable, is x naught, I don't know what is x naught, sine omega t plus phi. Interesting. Acha. Now this is going to be very fascinating. I don't need this anymore. Oops, I think I needed that. D square q by dt square plus we had few terms over here, and we had q minus q by 2 I think is equal to 0, and we had, I think there was 2 on the top, there was k, and I think yes, LR was also there. Yeah, so LR was also there. Okay, now let's try to identify all these terms over here. I think we can do that. How? Observe. Omega for a SHM is, if you remember, if you had an equation like this, m second derivative of x with respect to time plus kx is equal to 0. Omega was k by m. So over here, what is x? X is this part. Think about it. This is x, and this is your second derivative. So this whole thing is your k. If you notice, this whole thing is your k, and m is 1. So therefore, omega is nothing but root of k by m. That means 2k by LR. Check this out. Omega will be nothing but 2k by LR. Everybody getting it? Why you put calculus in EMI? Prasant, these are the kind of questions which come in advance. What do you think advance is? It will have all the concepts, maths, whatever you need will be there. What do you mean by why do I put calculus? That's how advanced. Please check all the previous year advanced question papers. Now, once I get this, the only thing remaining is x naught and phi. For that, use the given information. It is clearly mentioned at t is equal to 0. At t is equal to 0, this charge on the other sphere will be 0 because there will be no charge yet there. So q will be 0. So use this over here and see what do you get. So therefore q minus q by 2, but this q is 0, will be equal to x naught and sine omega t. Omega t will itself be 0. So 0 plus phi. And this can only happen if x naught is minus q by 2 and phi is nothing but, initial phase It's nothing but pi by 2. That's it. So I have got everything in this equation. So just substitute it and you will get the answer. So q minus q by 2 is equal to minus q by 2, and you have sine, and that omega, which is root of 2k by LR plus pi by 2. That's the answer. So just move it around and you will get it. And just move it around. Just move it around, you will get it. So just move it around. So q will be equal to q by 2 common 1 minus sine of something plus pi by 2, it will be cos. So cos of root, oh there was a t over here which was missing, yeah. So root of 2k by LR and into t. That's it. That should be the answer. That's it. Yep. Okay. That's how you do it. What an interesting question. This will decide whether you are in top 100, 500 or top 1000. That means whether you are going to get aerospace engineering or not, whether you are going to get mechanical engineering or not, whether you are going to get electronics, electrical and computer science engineering or not. Because the top branches obviously close somewhere close to 1000. Computer science to closes at all India rank 100, 200 and all of that, you know that. Okay, so that's how it is. Okay, so beautiful question guys, and I think we got it. Okay, so if they had asked something else at this time, what is the charge, you can substitute time and find out the charge. Next question coming up on your screen. Okay, I think I deserve to eat one kaju katli. I just have one kaju katli, I'll eat this. Meanwhile, you read the question. There is an inductor, there are resistors, battery connected, find voltage as a function of time. It's such an interesting question. Let's see how to solve this. Okay. Now, first of all, till now, you would have solved questions where there is a battery, there is a resistance, there is an inductor. But this is not like that. This is a problem where there are some parallel resistors, etc. An inductor is in parallel, and then you have to solve this question. In these kind of questions, there is one thing you need to do. First step, whenever inductors are not in series with resistors, first step, try to figure out what will be the final current, final voltage eventually when the circuit is closed for a long time. So after a long time, what will happen? Just check this out. After a long time, this inductor, remember, inductor will always behave like a wire. Inductor will always behave like a wire. So if this is like a wire, these are the two resistors. The current which will come from here, this current will flow here as well as here. Some current will flow here, let's say I1 and I2. Okay. Eventually, because it is behaving like a wire, the voltage across the inductor will also be 0 volts. It will be 0 volts. Whatever voltage is there, it will be there over here. This voltage will be there, but there will be no voltage across the inductor because it is eventually going to behave like a wire. This is at infinity time. Last thing that you need to do is make the battery, okay, or rather I would say make the battery into a wire, okay, and the inductor into 2 points, the 2 points across the inductor, like this. Open it up and find R equivalent across, these 2 points. Find R equivalent across these 2 points. What do I mean? Check this out. These 2 points, replace it across the inductor with 2 dots and draw the rest of the circuit, keeping in mind wherever you see a battery, replace it with a wire. That's the trick, not many people know. So this will become a resistor and this will be a resistor and there will be a wire across this. This is how the circuit looks like. Now, here is the next part. Not many people know this trick. Many people use derivatives and integration to solve the problem. You can completely avoid that using this trick. Observe, what is the equivalent resistance across these 2 points? Now check this, guys. Don't you see there is a resistor and there is a wire across this? The moment there is a wire across this resistor will become useless. This will become useless because all the current will flow through this wire. Nothing will flow through this resistor. It's a shorted one. So there is only one resistor here. So this will be the R equivalent. So the R equivalent will be just R2, which is how much? It is, I think, 2 ohms. Yes, so 2 ohms. Now most of the job is done. Most of the job is done. Now what you need to do, I'll tell you. See, once I have got this much part that the R equivalent is 2 ohms, the final answer will go like this. See, initially, think about it, initially, the inductor, everybody knows this, initially, the inductor behaves like an open switch. The moment you connect it, it will resist the current to flow. Hence, the final equation for the inductor, voltage drop across the inductor, initially it's like an open switch, there is no current. If there is no current, think about it, initially, what will be the voltage drop across these 2 points? Remember, there is no current only flowing initially. Initial current is 0. This is all initial. Initial current is 0. There is no current. There is no voltage drop across the resistor. So whatever voltage drop is here is over here. If there is some voltage drop between these 2 points, the same voltage drop is between these 2 points. And what is the voltage drop across these 2 points? It's the same across these 2 points. Think about it. These 2 points, and these 2 points have same voltage difference, because if there is no current, there is no voltage drop. The delta V is 0 volts over here. No current, IR is 0. So initial voltage drop, V initial, shouldn't it be 12 volts? Shouldn't it be 12 volts? Everybody getting it? Now, last step, the voltage as a function of time. It will be an exponential function. Everybody agrees. It will be the initial voltage into e to the power minus RT by L. That's it. That's how the function will look like. It will be an exponential decay function because eventually it becomes 0 volt. It starts with 12 volt. Eventually it becomes 0 volt. That's the whole logic. And now I don't need this anymore. And see what do you guys get. So V initial, so voltage across inductor will be V initial, which is 12 into e to the power minus R equivalent. What was the R equivalent? It was 2 T by L. What is L, guys? Where is L? L is 400 millihenry. So that's 400 into 10 to the power minus 3. Well, this will become 12 into e to the power. I think I'm probably starting to see the answer out here. So it will be nothing but, yeah, this will be 1 by 200 into 10 to the power minus 3 into t. So this will become nothing but e to the power, this will be 1000 divided by 200. 1000 by 200 is 5. So e raised to minus 5t into 12. So that is the answer, guys. Yep, that's the answer, which is option C. Yep, that's the answer. Interesting. How many of you loved this? Interesting question, right? Such a beautiful question. I mean, Surya, the KVPI sessions have already started. Crash course has started. You should join it. There is a link in the description box. There are lectures of physics, chemistry, maths, bio. If you're in SA and if you're in SX, physics, chemistry, maths already started with test series, with chapter-wise discussions and tests, and also the material for like assignments, everything, previous year questions, everything in the part of the crash course. It's already there. Check it out. There is a link. All right. Was difficult, but now you understood. Yes, that's what the whole aim is. Guys, if anybody has told you advanced is easy, they are lying. I'm telling you, advanced is hard, but you need to learn it. When you learn it and when you see that, yes, I can do it, yes, you can solve it, you should feel that it is easy when somebody solves it for you. And if you're getting that feeling, yes, it looks solvable with effort, that means you're on the right track. Okay. Yeah, that's the answer. Let's go to the next question. This is the most easiest question over here. Let's see if you can solve this. The answer to this question can be either increase, decrease, same, or can't say. Come on, answer this. Read the paragraph and answer this. Is the answer increase, decrease, constant, or cannot say? Come on, come on. Thank you, Trapti, saying that Rakhis are very nice. Thank you. Okay. See, when there is current induced, because of this current, you know, there will be some magnetic field which will be passing through this. And by Faraday's law, you know, there will be some, how does the magnitude of the current in coil be? Okay, so there will be some current over here. So this current will be EMF by resistance, which is d phi by dt. So there will be some current which will be introduced in this circuit because of the flux. Now, the moment you have a metallic plate, what change will happen? There will be current induced here as well. These currents are called as eddy currents. These currents are called as eddy currents. These eddy currents will oppose the magnetic field lines. These eddy currents will create new magnetic field which will oppose the original magnetic field. So because of that, this flux will decrease. This flux will decrease. Hence, this current will also decrease, bacha log. That's the final answer. Understood? Yes, Zayed, your messages are visible, bacha. Okay, Neeraj, I hope it is understood right now. Excellent. Okay, so Roshan also says yes. So the whole idea was on eddy currents. Eddy currents are set up in any random conductor. These eddy currents' job is to oppose the change. So the moment eddy currents are produced, they will produce new magnetic field, and that magnetic field with the previous magnetic field, they will be opposite. So the total flux would have reduced. Flux reduces, EMF reduces, current reduces. So that's the answer. This question was based on eddy currents, and the answer is decreases. Very good. Next, before we go ahead, if you want more such questions like this, use this material. Before we go ahead, let me tell you, this is the material you need to use. In this, there are easy level, medium, previous years, then advanced, more difficult, and previous year advanced. So gradual increase of questions. Everything is there in this with concepts, formulas. You will get it when you join the pro subscription. Second book which I have recommended is H.C. Verma. Solve H.C. Verma, Tathwa, and then in the end start solving Eurodo. That's all you need, apart from previous year questions. That's all you need to clear advanced examination. Okay, cool. Let's go to the next question. This is not so difficult. I'm pretty sure you will get it. Come on. There is a wire. It has uniform, resistance everywhere, and there are diameters CD and BA. And the question is, if you move this setup over here with some velocity, what is the current and EMF across this and this? Very beautiful question. Let's try and solve this. First of all, I want your focus to be only on this much part. This one which I am shading right now. Nothing else. That's it. Only this much part. Okay. I hope you can see the shaded part out here. So quickly tell me, if this part moves right side, what will happen to the flux in the shaded region? The flux in the shaded region. Will it be constant? Will it increase? Will it decrease? When you move it right side like this in this uniform magnetic field with constant velocity. Think about it. Thank you, Sagnik. If you move it there, will the flux through this OCBO part, the quarter of the circle, increase, decrease, or remain constant? Think about it. Think. Will it increase? Will it decrease? Or will it remain constant? Think. Come on, my warriors. Push yourself. I hope you can see me. I hope you can. No change, Kamlesh. Very good. It will not change. It will be constant. Why? Because whether it is here or whether it is here, the number of field lines over here and here will be same. So same number of lines, so flux is constant. If flux is constant, that clearly means using Faraday's law, I can easily say that the EMF, net EMF induced is 0. Hence, the net current in that part is also 0. Interesting. So there is no current as such flowing in this part because the net EMF is 0. But that does not mean individual parts will not have EMF. Individual parts may have EMF, just that they cancel each other. That's what is happening. Now, I had given you one theorem which said that, the moment you have a curved part, you can replace it with a straight part. The EMF in the curved and the straight wire is always the same. Do you remember that? So EMF in the curved and the straight wire is always same, motional EMF. Okay, so that's a property which I had given to you. So that means the EMF across this whole part from OCB across this curved wire, shouldn't it be the same as the EMF across the straight part? Correct? The EMF across this whole part is the same as the EMF across this part. Cool? Now observe this. Just find what is the EMF across OB, because they have asked what is the current and EMF in OB and BC. Okay, let's find OB first. Now use the formula EMF, but this is across OB, understand that. Okay, this is across OB, will be L dot V cross B. I have given you this formula, L dot V cross B. Where is velocity? Right side. Where is magnetic field? Inside. V cross B, where is it? Upwards. Remember, the direction of EMF is always given by V cross B. So EMF will be this way. So this EMF will be this way, V cross B, that's fine. Velocity cross magnetic field, it's going to be like this, and length is also that way. Cool. You can see length is also that way. So you are going to get LV. By the way, length will be radius, V is V and B is B. Okay, and it will be in this direction, upward direction. So I can probably replace this with, probably something like this. This is that EMF. Okay, this is that EMF. Okay, probably, I hope this is now making sense. Okay, now once I have found this out, this same EMF will also be there across this whole part, but there is a small catch. Just check this CO. What will be the EMF across that part? CO, only CO. I know it is L dot V cross B. Yep, it is. Now carefully observe, where is velocity? Right side. Where is magnetic field? Inside. What is V cross B? It is upwards. So V cross B is this way. V cross B is upwards. Length of that CO vector is this way. So if you take the dot product of two perpendicular vectors, it will be always 0. So there is no EMF across this part. There is no EMF across this part. That means whatever EMF is there in the part OCB is only because of CB. Everybody getting it? Whatever EMF is there across OCB is not because of OC, because OC is giving 0 EMF. That means the only EMF is CB. And how much EMF is there across OCB? Exactly this one. This is also the EMF across OCB. And EMF across OCB is EMF across OC plus EMF across CB. Now this part across OC is 0. So that will be EMF across CB. That's it. I have got that. So what is the EMF across CB? It is also RVB. That means I can replace this part also with a battery like this. Only this part, only this OC part does not have any EMF. So I've got the answer. I've got the answer. So EMF across OB is RVB. EMF across CB is also RVB. EMF across CO, 0. These two voltages cancel. Same voltage is opposite. So the current is 0. Remember, current will be 0. Such a beautiful, conceptual, interesting question. Beautiful question. Okay, so let's get going ahead to the next one. Amazing question this was. All right. Yep. So 0 amperes in both the parts, but RVB in all these two parts. Okay. Beautiful, beautiful. Okay, cool. Now let's go ahead to the next question. and I hope you'll be able to solve this in a very beautiful manner. There is a wire ring of radius r and it is fixed over here in the horizontal plane. The wire of the ring has some resistance. There is uniform magnetic field, okay, in the entire space. The ring, the perfectly conducting rod is along the diameter. Now the rod starts to move with a constant acceleration a in the direction perpendicular to its own length, like shown. Find the current to the rod when it has moved a distance of r by 2. Now this is such a beautiful question, trust me on this. First let's think what is happening. Okay, so there is magnetic field, it's clearly mentioned in the question. This is moving, so motional EMF. So the moment there is EMF, what will happen? Because of the resistance, there will be current. Okay, so let's draw it at a distance of r by 2 after it has traveled r by 2 distance right from the start. So after some time, this rod is going to be here. Observe, this rod is going to be here. And this distance is nothing but x, which is r by 2. And it also has some velocity at this point. And this velocity can be easily figured out. V, how do you figure it out? Use kinematic equation. Using kinematic equation, you can get it. V square is u square plus 2a s. S is x over here. So V will be root of 2a x. How much is x? R by 2. Okay, interesting. So velocity is root of ar. So I got this. Velocity is root of ar. Interesting. Now, there will be EMF across the rod, but the points which are of interest is only these 2 points because they are in contact with the ring. That much part will create EMF. These 2 parts are outside the ring, so only this much part will be the battery. How do I find that length? Because only this length is what is my effective length. How do I find that out? It's easy. Drop a perpendicular, draw this line. This is radius. This is r by 2. Guess how much is this? It's a right angle triangle. Everybody should be able to guess it. So what's the base? What's the base of that right angle triangle? That base is nothing but root of r square minus r by 2 whole square. So that is going to be root 3 r by 2. But I don't want just the base. I want the total length because that's the effective length. So what is the effective length? That effective length is this multiplied by 2. So root 3 r by 2 into 2, which is just root 3 r. Why do I need this effective length? Because I can get the EMF across that. EMF will be obtained once I know the effective length. So what is that effective length? Think about it. That EMF will be L effective into V into B. What is L effective? This part, which is root 3r. What is velocity? Velocity is root ar. Okay, root ar into magnetic field, that is just B. Just substitute it. So I'm going to get root 3ar into r into B. That is my EMF. Interesting. But the question is not EMF, find the current. The question is to find the current. You'll be like, sir, I know EMF, find the resistance, that's it, job done. Trust me, it is not so easy. It's not so easy. I'll tell you why. Okay, I'll just remove this because this is no longer needed. Remember one thing, yes, this part will behave like a battery, undoubtedly. This much part will be like a battery. Okay, this will be like a battery. But do you think the current will just go like this? No. If this is a battery, guys, think about it. If this is a battery of some EMF, this much, the current from here is going to get distributed in 2 parts. Don't forget, the current will get distributed like this, like this, like this, and eventually come over here. That's how the current is going to flow. So there are 2 resistors in parallel. Do you see that? There are 2 resistors in parallel. That's the one you need to account for. Interesting. Very, very nice. Okay, so when I drop a year, can I just watch your classes with those assignments? Yes, Bacha Master 08, I'm not ignoring. You can watch. I'm just concentrated on this question. I'm completely involved in this question because this is such an interesting question. So that's why. But every doubt that you have, guys, you can leave it after the video ends. I'll respond to your questions as well. Okay? Chalo. So, what will be the resistances? For that, think this way. Okay? Think this way. The resistance is proportional to length because it is clearly mentioned the resistance is lambda ohms per meter. It's lambda ohms per meter. So what is the length of this minor arc? What is the length of that minor arc? Okay, you can figure this out. How? I'll tell you. See, this is r by 2. This is r. So shouldn't this angle over here be just 60 degrees? Because r cos 60 is r by 2. So this should be 60. So what is the total angle subtended at the minor arc? So what is the angle? What is the angle at the minor arc? The angle at the minor arc is 120 degrees. So the length of that minor arc will be the total circumference 1/3 part, which is 2 pi r by 3. Why 1/3? 120 is 1/3 of 360. It's 1/3 of 360. That means it will be 2 pi r by 3. That's how I got it. Okay, cool. What will be the length of the major arc? The length of the major arc will be total circumference, which is 2 pi r minus 2 pi r by 3, which is 3 2 is 6, 6 minus 2, 4. 4 pi r by 3. Interesting. Length is obtained, resistance. So resistance of the minor arc will be the length into lambda. So it will be just lambda 2 pi r by 3. So resistance of the major arc will be lambda 2 pi r by 3. That's it. Sorry, 4 pi r. Lambda into 4 pi r by 3. That's it. So resistance is obtained. So what will be the R equivalent? It will be R minor arc into R major arc because they are in parallel upon R minor plus R major arc. That's it. So just start substituting and see what do you get. Okay, so yeah, so the minor arc, that's got lambda into 2 pi r by 3 into lambda into 4 pi r by 3, the whole thing divided by lambda into 2 pi r by 3 plus lambda into 4 pi r by 3. Okay, I don't need this anymore. I'm just going to erase this part. Okay, fine. So what's going to happen, guys? You're going to get 2 into 4, 8. So 8 lambda square pi square r square by 9. And below, you're going to see, well, 2 plus 4, 6, 6 by 3, 2. So you're going to get 2 lambda pi r, and probably you're also going to get that 3 over here. Yep. So this 3 and this 9 will become 3 like this, and a lot of things will get cancelled. So I should get 8 by 3 okay, sorry, 4, because even that 2 will also get cancelled. So 4 by 3. So 4 by 3, lambda will be there, pi will be there, and r will be there. Just check this out. If this is fine. See if you have not made any mistake or anything. So 2 into 4, 8, cool. 3 into 3, 9. 2 plus 4, 6, 6. Oh, that 3 has 3 was not there. My bad. Sorry, guys. This 3 was not there because 2 plus 4 is 6. 6 divided by 3 is 2. So 2 lambda pi r. Yes, as it is. So this should be 9 only. Yep. This should be 9. And yep, this should be 4 divided by 9. Yeah, now it makes sense. Just check this out. Yep, check this out. Yeah, 4 by 9. Yeah. Now, once I have the R equivalent, you can easily find the current. So the current will be EMF by R equivalent. So just substitute everything. So root 3 AR into RB, the whole thing divided by that number. So 4 lambda, okay, 4 lambda pi R divided by 9. So into 9. So this will become 9 by 4. RR goes, and I think everything else will be there. So root 3 AR, RR will go, and B will be there, and 4 is already there. So lambda pi. That's it. That should be the answer. This is the final answer, guys. Just check this out. 9B, yeah, by 4 lambda pi by root and into root 3R. What a beautiful, beautiful question. Zayed, the captions will be visible only after the video is over, after some time, not before that. Okay, so that's how you do it. Now, should I give KVY SX? Yes, Ankit, definitely. Now, I have kept 2 questions for you guys as homework. Promise me you will do it. Promise me. They are not that difficult, but I'm pretty sure you can do it. Okay, so this is the answer. This is your multiple correct answer. Oh, there is only one question. Yeah, this is the question that you need to solve. Oh, don't see the answer. Yeah, so this is the question which I have kept it for homework. Please put the answers in the chat box after the session is over. Right now, if you're watching this video, let me also tell you one more thing, that if you want more such problems like this, I have conducted problem solving course for 11th standard chapters. Soon I'll be solving problems of 12th standard chapters, mains level and advanced level separate. Okay, and there is HC Verma solutions. Also there are many micro courses and my courses which are available for you guys to watch for free as a part of this subscription. Number 1, there is SX batch for KVPY. You can check this out. There is a SX batch. You need to log in and you just need to pay 4,000 rupees to join the KVPY SX, the 12th standard KVPY course. If you just want KVPY course, go over this link. But if you want regular batch along with KVPY, go to the other link. This is your complete 12th standard course. Along with revision, JEE Mains and Advanced. Also the booklet which I showed you will be couriered to you. All the booklets, all the subjects, physics, chemistry, maths. Now, a lot of people have the confusion, sir, which version should I, which package should I go? See, everything is there. Test series are there, assignments, everything is there in all the 3 versions. In fact, all the 3 kinds of students sit in the same batch. The only difference is the classic student will get doubt solving on the mobile app after the class also, and the plus student will also get personal mentorship if needed for making timetable strategies, whatever help you need. All the other things are common, nothing else is different. Most of the students go for classic, and some students who need special help go for the plus version. Even if you go for the light version and try it out for 1 month, it's hardly 3,000 rupees after you use my coupon code, which is SHSPRO. So try it out at least for 1 month. Trust me, if your coaching institute has not taught you these kind of questions, then something is going wrong somewhere. All right. So please make sure that you study the right way and from correct sources and to the correct level. You should not be surprised when you see the JEE Mains and Advanced question paper. Arey, ye to padha hi nahi tha. What is this? How to solve these kind of questions? So all the varieties of questions from different materials are given to you so that you do not waste your time. We have to waste our time to make sure that you get the correct content. Your time has to be utilized for solving problems. So it's our job to give you those questions. All right. So I'm hoping that I'm going to see you, some of you at least, in the pro subscription, and you can also join my micro courses for free of cost, because it's like joining, Netflix. You join Netflix, you get all the movies for free. You don't have to pay individually. Okay. Chalo guys, I hope you guys had an amazing session. All right, Neeraj is back, but I hope you can watch the replay of whatever part you missed. Thank you, Riva, for promising. Well, Nikhil, Ankit, don't lose hope. And NIT Goa or SRM or Josh, I would say NIT Goa any day. Okay, so Revansh, keep this Josh high, bacha. I would love to see you guys motivated like this. Without any subscription, Farhana, you will not get those materials. Okay, chalo guys, bye bye. That's it from my side. Take care, have fun, and all the best. And please revise through the backlogs. There is already one video which I just made just few days back over here on our channel. Please watch that. This is for all the 2020 students over here. See this. Where is it? Yeah. JEE 2022. Are you in 12th with backlogs? this is the JEE 2022 alert which you need to watch. Okay, so this is the exam related details, the timetable, how to manage school and coaching, everything, all the tips to become a topper and crack JEE Mains and Advanced examination. So check it out. Thank you guys for being here, tuning in. Have a great time. And this was Shreyas here, your physics master teacher at Vedantu. Hasta la vista. Oh my God, Lakshmi, sorry, you asked me a very important question. You have paid 40 rupees. Thank you, bacha. I cannot ignore you. Sorry. And Lakshmi has given a super chat. Sir, the best books for physics for aiming top rank. The best books for physics for aiming top rank, I'll just tell you, it's over here. See in this video. Let me just skip this ad and I'll show it to you. Okay, over here. I have probably given it somewhere here. Maybe here. Yes, this is the one. So notice the timestamp. It's 2006, somewhere around that. I've given all the books, physics, chemistry and maths, theory, problems and advanced. All the books out here. Okay, so that's it. That's how you can check out all the books. Irodov is the book you need to use, and previous year questions of mains and advanced, all of that along with Tattva. Tattva also has advanced material. So this book also has advanced. This book has advanced. Okay, cool. Chalo. So I could not ignore the super chat because Lakshmi has paid 40 bucks for just getting the answer. I mean, really thank you, as well as I'm pleased and you guys trust me so much. I'm really happy about that. All right. Take care, guys. I hope Lakshmi have answered your doubt satisfactorily. Take care. Hasta la vista now.